Want to nail engineering manager interviews at MAANG and other top-tier companies? You can with USA's #1 tech interview prep platform. We have 300 plus SMEs and instructors from top-tier tech companies to help you land your dream job. We've helped thousands of engineers make their way into MAANG. You could be next. To learn more, register for our free webinar.
Hello.
Oh, hi.
Hi. How's it going?
Can you hear me?
Yes. Can you hear me?
Good.
How are you doing?
Not too bad. Getting busy at work, but it's been a long day, so hope you don't mind. I'm drinking a beer.
Yeah, sure. Cheers.
Is that your view, or is that
No, it's a virtual background.
Oh, okay.
Yeah. Hopefully this will be my view sometime later.
So
Yes.
so I was wondering I was wondering if I could work on a problem with you that come up with, that I'm facing actually,
Okay.
and get your thoughts on it. But did you have something that you wanted, just to get a sense of, if if I didn't suggest this, what kind of problem you might? Yeah.
Yeah, sure. So first are we talking about system design problem or
I would call it an NLP, data science, maybe machine learning, um, to some extent system design kind of a question.
okay. Sure, we can do that as long as it's within the scope of interview problems.
Yeah,
Okay.
absolutely. If it's not something you're comfortable with, absolutely.
Sure.
But I'm just kind of curious if we didn't do that, because it might help me think. It might help me prepare for a later one. If
Yeah.
So, like, what was the topic? Um,
Yeah, so I was thinking about something in the lines of ranking systems, which
okay.
is it's kind of a common question people ask, but we can do something. I guess if you have a problem you would like to work on together, that we can do as well.
Yeah,
Either way.
and ranking of what?
A ranking of newsfeed.
Okay. Okay. Cool. Okay, I'm trying to pull up the right. I should have. Yeah. So I'm a little behind here. Let's see now.
Right.
Oh, that's why. Okay. Sorry, I'm just trying to get the right
Sure.
window open here. Yeah. Okay. I've got all these files and all these different things, and I have this way of organizing, and it just takes me a while to get configured, because I hadn't got this whole Emacs set up to handle interview Kickstart.
Mm.
I bet uh, I bet you don't use Emacs or VI, right?
No, that's something that I never got a chance to learn, and so
Oh darn! Why isn't this? This is not behaving correctly. Darn it. Okay. So I will just go into Bruce Force here. Okay, I'm getting better now. Okay. Um, two. Okay. And up. Francie's coming back. Naomi, my daughter likes to come in and interrupt my videos, and now she's being all silent. Well, as long as she's silent and not distracting. Um, okay. So, yeah. Okay. So, ranking of news feeds. So here's my thing. So let me run this by you and see if it seems comfortable. So the goal is to create data for autocomplete or auto suggest. So like when you type in Google, you might type in the Declaration of, and it will give independence or
Hmm.
sovereignty or human rights, right?
Yep.
And um, independence will get the highest ranking. Um, but this is so we need to build data to tell autocomplete what to do.
Hmm.
And the focus is medical. In particular, we want to identify symptoms related to body parts. So so what we want is like head hurts, or eyes hurt, or bloodshot eyes, but not
Hmm.
bloodshot bones. That would be nonsensical.
Okay.
So so the input is initially just a list of body parts,
Okay.
including organs like uterus, ovaries, and then more obvious things like hands, head, eye, and then a list of symptom types like hurt or pain. And then within pain, there's a bunch of phrases like hurts, um, hurting, is hurting, right? And so some of the phrases are before body part, and then some of them are after. So there's two types of phrases. So you might say head or arm hurts, elbow hurts, or elbow is hurting, head
Hmm.
is hurting, or hurting head. So hurting is both a before and an after phrase type. And then sometimes you have, I mean, so like the so like to start to seed it, you can just take lists of body parts and multiply them. I think the correct term is to take the Cartesian product of like each body part in your list and then each phrase. So you'll generate eyes hurt, heart hurts, face hurts, bones hurt, or bones are hurting. Well, bones is hurting, eyes is hurting. So you'll
Hmm.
have so there's some problems with the brute force approach. So you could have is hurting and are hurting, and then you're going to have to generate bones are hurting, bones is hurting, and then you're going to generate all this stuff and then feed it to human raters to say, initially relevant versus non-relevant. So um, like bones, itchy bones. So itchy is not a symptom type that would apply to bones, but
Hmm.
is a symptom type that would apply to skin or whole body.
Hmm.
And so again, under the symptom type of itchy, there would be different phrases like is itchy or itches. So X is itchy, X itches, or itchy X, but not is itchy X. Right. So there's this notion of before and after phrase. So so that's like the starting point at least. And so we do have some human raters, but we don't have a lot of human raters at this point. Maybe later we'll get budget for Mechanical Turk. Um, and then, and then you can do things like, um, why don't I stop there? So there's like how to do it. Um, and then there's questions of like data structures.
Mm.
Um, yeah.
Okay. Do you mind sharing a doc or something
Yeah.
writing on?
Yeah. Writing. Yeah. 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 Okay.
Yeah.
Perfect. Yeah. 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 Screen share. Oh, I need to press the share button. That's why it's not sharing. So does this sound appropriate, comfortable in scope? Yeah.
Yes.
Oop.
As
Yeah.
long as it's a generic problem and it's not, relevant to, specific work project, just to potential conflicts of interest, it's fine. I mean, just so far, so far this is a problem we can work on together.
Right. Right. Well, Mimi, Mimi, please, Mimi, I'm busy here. Naomi. Yeah, it's hard when my wife has to make dinner. It's hard to get total control over the kids. So yeah, so it is arguably a generic
Okay.
problem. It could be a different domain.
Yeah.
Um, and so 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 yeah, like ask me a question, maybe.
Yeah. Sure. So first thing I want to let me see if I can see what
Oh,
you
I didn't
shared.
write much. Should I write more? Like, should I?
Yes, just want to see some of the examples of, I guess, uh the sentences or utterances you
Yeah.
consider. And I guess one question would be, are we thinking about autocomplete in character level, or like word level or token level? Is
Oh,
it
good question.
yeah
Um,
like, for example, if I type, I don't know, if I want to type bone, like if I type BO, should I expect to get the bone as well? Or no, if it's like I type bone and then I expect to get suggestions for hurts, etc. Painful, it's painful.
yeah. Yeah. So, yeah, character level.
Character level? Okay.
Yeah.
Okay. So, and okay. Is it, do you want to work through it together, or you want to, you know, work on it and get feedback, or how would you like to,
Um,
you know?
yeah, work on it together.
Okay.
Yeah. So, or no. Um,
So,
so this is the
yep.
base. This, yeah, yeah.
Okay. So exerts, inserting, and then um and then what is the before after here?
Um, so in other words, the before phrase is just where you take the body part and you. No, I'm sorry. Yeah. Um, the before phrase is when the phrase when the phrase comes before the body part term, right? So this would be painful head, painful skin,
Hmm.
hurting head, hurting skin, hurting heart, but
Okay.
probably not hurting hurting adrenal gland, right? No one would have any idea that their adrenal gland is hurting. Um, X hurts, X is hurting, X in pain. That's an after kind of auto.
Okay.
Um,
Oh, so do we expect to say to get X when we say X hurts? Is that sort of thing?
um, right. So if you type in, um,
Now let's type in actually an example. Like let's just
yeah,
start typing it and see in the use case.
right. So, like simple, obvious autocomplete is you just type in pain, and then
Yeah.
it would suggest, like if I typed I, then it would
Mm.
give, two things. It would give, um, no, I'm sorry, not pain. Head,
Mm.
head I. So if I typed in head,
Mm-hmm.
type in head I, then based on the above, multiplying it out, I can
Mm.
get head is hurting,
Yeah.
head in pain. Those would be
Yeah.
two.
Okay.
Yeah, and then um, so you want to preferentially um, give some, but then if you're going to say is hurting and in pain, those are redundant, right? Because they mean the same thing. But so you actually wouldn't. So you would maybe know about in pain and in hurting. But if you saw it
Yeah.
head high, you should say head and then maybe say is in pain and then head itches.
Okay.
So your data structure would know about head is itching, head itches, and so head itches n plus one um plus one, head is itching, right? So these two guys are synonymous, and these two guys are synonymous. So if you type head A, only get head in pain. Yeah, and I'll call this one, I'll call this one B, and I'll just call this one R. R means relevant. B means it's one of the best.
Yeah.
So this B is better than that R. So you'll say head. So you'll only want to get head in pain and head um, or head itching.
Okay.
So is that kind of clear?
Yeah. So also for the other one, for the other after phrase, can you give an example of that one? Like how the use case
Yeah.
for that we
Um, well, actually, these are after phrases, right? Because this is X is hurting, so the phrase comes after the body part. So the other option is the before phrase.
Okay.
So if you type in, so I'll say example of using before phrase completions, and then example of using after phrase completion. So an after phrase completion. So that means after, maybe after body part, phrase completion, after body part, before. So before body part phrase completion is where um, well, here to make it clearer, um, it's body part before phrase body part. There, this makes it the clearest. Right, so here the body part is after the phrase. So an example would be, um, so let's see, after, so then that's X hertz. Oh, wait. Oh, geez, I'm keep confusing the terminology here. So body part, I'm sorry,
No worries.
yeah, after um, phrase is after body part. So we're calling that an after phrase because the phrase is after the body part, and then phrase is before the body part. Here, and this seems like such a common problem. Everyone, has to solve this, and I hope I'm not like just go gallivanting off in some. There's some much simpler way. Um, but so anyway, so an example of a phrase is before body part. Phrase is before the body part would be like, so you type in pay. Let's say you type in um, pain, or let me see, a good evocative answer. Let me look. Let me go up here and see if there's some other good sentences. And okay, autocomplete. Now I'm going to use the an anatomical parts list, and then sort of symptom phrase list. Well, how about there's symptom types, and then so there's pain, um, bleeding, inflamed, um, what's another example of a symptom? Itchy, hot. So these are what I'm calling symptom types, and that's why I put a $# in them, because that's just a way of saying it's a concept. And concepts have synonyms, and the
Okay.
anatomical parts have synonyms too, like um, um, these aren't good examples of synonyms, but um, well, let's say, oh yeah, head. So so you'll have head, noggin. That's a little unrealistic, but let's just say um, that's an example of a synonym. Or maybe you'll even do like hand, hands, palm, palms. Oh, eye is a good one. Eye, right? Eyes, etc. And then so then these synonyms, these each pain, it has each symptom type has um, I'll call them synonyms, or really phraseologies, synonym type phraseologies. Ologies, right? So, and of course, my spelling is terrible. And there's two types, right? There's the two types is before and after. Um, and so what I was talking about for pain, let's see here, pain. Um, yeah. Okay, so I'm so phrases after, right? Um, so you would say pain hurts, pain. Oh no, I'm sorry. Head hurts. Head is hurting. Head in pain. Painful head. Hurting head. And then you remember some of our other body parts were skin. Let's say, or no, uterus is a good example. Pain. So we'd have uterus hurts. Uterus is hurting. Uterus in pain. Painful uterus. Hurting uterus. But itchy uterus, wouldn't make sense at all, right? Um, you know, so the task is given a phrase like itchy uterus. Um, Determine whether it's sensible or not. Make sense?
I was mute. I see, but okay. So is the task to check if a given phrase is valid or not, or if it's to autocomplete given maybe one word on some letters to make suggestions?
Well, the task is to create data. So to create a list of all and only the valid phrases to tell autocomplete what to do.
Okay.
There will be another thing that takes in a list of phrases and figures out the autocomplete. So
Okay.
it's not an algorithm. It's a language generation problem.
Okay. Okay. So basically we're talking about two parts of it. One, the language generation for valid phrases, and then the other one on the autocomplete side of it.
Right, and I'm not at all
Okay.
interested in the autocomplete algorithm,
Okay.
just the data generation.
I see. Okay. So on the data generation, then well, it kind of depends on how you would like to have the autocomplete, because for the autocomplete, like the simplest way is to use the tries data structure, right? And that is given you're given some sentences, you just basically fit them into that try, and then it basically includes all the valid sentences, and it's pretty rigid, right? So if it's there, it suggests; if it's not there, it doesn't. Kind of a hard-coded thing. But then if you want to do something like a language model, which is still based on the data, but it's like more of I guess it's kind of more flexible. And then for that, you need to generate a lot of, examples, like it's variety of examples. It could be repetitive, etc. Like considering all the synonyms, all sort of stuff. And for that, I guess for either case, I guess one simplest case would be to have a grammar with these certain, I guess, token types or whatever you call them. Let's say on the itchiness, pain, etc. body parts that you can have template sentences, utterances, and then generate out of different combinations. That could be data. And if it generates only unique possibilities, then it's just, that's going to be some good data for using a trie data structure. But then if you want to be more pluralistic, with something like a language model, that it's more than generating the unique ones, putting some weights on the ones that are like more important or more, frequent or more probable, and the less probability on the ones that are less probable or less common, etc.
Yes.
Yeah, but that would be one way, I would say. Grammars and generating out of those grammars. And this is like, I assume this should be pretty small, set of sort of different utterances. It's because it's pretty specialized on this application that you're talking about, rather than a very generic, language model for anything that you want to search, right? It's pretty narrow, right?
Okay. Well, I mean, the concept of using a grammar could work whether it's narrow or broad. But if
Yeah,
it's broad, the complexity of your grammar or the number of rules will be greater.
yeah,
That's kind of what you're saying, right?
yeah. That's in terms of scaling it, because grammar is harder to scale. That if it's like a larger scale, maybe something like a model, an NLG model or something like that. Just training a model would be something that makes more sense. But if it's not a large scale, grammar, I think it works well. So depending on the scale of the domain, but I guess based on what I'm seeing is, I guess, pretty focused on like some, let's say, I don't know, like medical terms on um, symptoms of, some problems in the body, which should be, I know, my guess it should be limited, right?
Yeah. So the NL generation model, you know, to me it seems so. The problem with any ML model is that you need the training data. And
Yeah,
so to bootstrap to get that training data, what about starting with a grammar and then, over time, especially when you want to give a ranking to every phrase, you're going to have to leave a grammar because you're going to have to leave the world of grammar and go more towards an NL generation model. But to
yeah,
get yourself there, you'll use like a combination of a grammar generator to generate a lot of phrases, and then have humans
yeah,
the ones that it over generates.
yeah. And the question of like writing a grammar or not, I guess it would be also on the question of if you have any, such sort of data, maybe on a textbook or in a reference document or something that could be just read and used. If that's the case, it could be, maybe directly used for a model, training a model. But if it's not, then if you don't have, phrases, utterances for this particular, use case, then just yeah, writing grammar would be the first thing I would say, or based on what I yeah.
Right. And so, how does one write a grammar? I've heard of GRXML. You heard of GRXML?
GRXML, no.
No.
There is well, back in old days, and the way that we used to do it was um, there is an algorithm for that. Basically, you just there is this language. I forgot the language name, but you write the grammar is basically just simply as like writing utterances in a text file uh, with within it's a particular language I forgot. Like you use like these and or etc. as like an um, parameters for the words that are not fixed. Let's say that I guess one example that we have, like for example, if you wanted to talk about I don't know restaurants etc. Like I want to go eat something somewhere, like and the name of the restaurant is a variable thing that could be anything, right? So there's a term I forgot the terms, but you write it similar to what you were writing here, like with special characters like the dollar sign or like the shop, etc. And then you put a generic term for that
Yeah.
instead of let's say bone, skin, hand, etc. Or like whatever McDonald's in and all, etc. You put restaurant name, and then there is you're gonna have a separate file that includes all the possible options for that generic term, and then there is an algorithm that kind of randomly selects one of those and generates an utterance. There is, I guess it was I forgot, like CFG grammar. I'm not in LP anymore. I forgot all of those.
Yeah. Now, and you're not thinking of a finite state automata, are you?
um,
Because
let me see. This context-free grammar. This is
okay.
yeah, context-free grammar is CFG. It's a language. Um, not the language. It's a I don't know. What do you say? Standard, you know, language for writing grammars. Basically, you have a grammar, and then you have this terminal symbols, non-terminal symbols, and then some rules. And then based on those rules and the symbols that you have, it generates all different possibilities. Um, and then
Right.
there are different ways of doing it. Yeah.
But is there like a standard? There's must be some standard tool.
Yeah. There,
And
there,
yeah,
yeah.
this is
There are, there are algorithms for that. And hmm, there are, I think, Python packages that do this as well. Uh, I remember we used to have some customized code for that, but I'm pretty sure there is because this is also part of, how do you say, part of, it's pretty standard, topic in general, like NLP courses that I had read about that, and they talk about this context-free grammars like all over the place, and I'm pretty sure it should be packages that they do it
yeah,
uh, automatically. It's just writing it in that language, and then writing it in that language. Once the standards, it's just writing whatever you want in a text file, and then it generates everything, all the possibilities. So
yes. Um, yeah, that's a great suggestion. It's the kind of thing that is on the tip of my tongue, but I wouldn't search on it. I just start hacking. You know,
yeah. Let's
I've
see.
been hearing about these context-free grammars, and basically, when they say context-free, it means that context is not involved, and so the surrounding. So in other words, um, the like the sentence before is irrelevant to, or what does it mean to say?
Yeah.
You remember?
Yeah, so it's not like it's not smart to generate based on a context of like previous or like next words. It's not doesn't have anything similar to what language models do. It's
Mhm.
as simple as you have some fixed symbols that I guess that's where they call them like terminal and versus non-terminal, and then you have the ones that are not fixed. It just generates out of those with different combinations. And then when you're also writing your grammar, it's not just the symbols, but you can also say that, for example, you want to say my whatever head uh, is something, or uh, like is hurting or hurts or is going to hurt. You can have like all this. These are like a logical rules that you can say this or this or this should be one of them. And then you can have like and logics, and they have like some sort of logics that like pretty much like uh just the simple logics that you can use like and or etc. And then these symbols that you can replace with a list of tokens from somewhere, and it basically takes the rules, those symbols, and the possible options, and then generates all the possibilities.
Yeah.
Um, and then for that, you can also do again. You can have generate all the unique utterances, or you can generate it in like with some weights. Like there is an option to weight them. Like I want to have more of these sort of utterances or the other ones, and then that's not unique. Like maybe you have, I don't know, 10 utterances of the same thing or pretty much similar versus like one example of another rule. So these are like things that kind of can play with it if
Right.
you don't want to like have a uniform distribution of the utterances over the rules. Yeah.
Um, okay. So then, um, so the idea is to write a find some context-free grammar package, and then write a few of these production rules, generate
Yeah.
phrases, and then have humans comment on the phrases, and the ones that are not relevant will just get xed out, and then
Yeah.
try to refine the grammar to make it generate more accurately. But it's only going
Yeah.
to do so well, and then you get a whole bunch of phrases, and then just feed them to the try thing.
Yeah.
I will make the try.
Yeah.
Um, and um, so where am I getting hung up here? But um, so and then there's thing that it comes in waves. So like to actually do this in a production environment, you'll generate some things, you'll get some ratings, and then you'll realize, oh, I forgot about this other symptom. I forgot about this other phrase
Mm.
that goes under pain. I already have pain. I have is hurting and hurts.
Mm.
It's like killing. If it's really hurting, you say, oh, my head is killing me. Right?
Mm.
So you forgot about killing. So then you generate again. And so now you have to generate, and then you have to realize, am I generating something that hasn't been rated yet or not? And then so the things that aren't generate that you haven't gotten ratings on, then you want to show those to your raters, but you'd prefer to show them in the full context. In other words, this group of raters is already rated, is hurting and hurts, but now there's kills and is killing, and so they
Mm.
can see how they did the others, and they can go more quickly if they see what they did for others. And so, um, so trying to figure out, has this been rated already or not? So maybe the way to do that, data structure wise, is to read. So you have a table of all things that have been rated, and so the column is the index column is the phrase. So it would have things like uterus hurts, skin is hurting, itchy skin, etc. And then, let's say you wouldn't have sweaty. You don't have sweaty skin. Um, and so you would just hash, or in Python, you make a set of all the things, all the phrases, and then you're going along. So you're generating new things, and you say, "Oh, I'm generating a fresh. Oh, I already have head is hurting, but I don't have head is killing."
Mm.
So then, what I want to do is put head is killing right in the right place in this list. And that's what I'm struggling with, because if I just had a set or a hash, if I just hashed on the thing that would tell me quickly, yes, we have rated this versus no, we haven't rated this, that won't be any good. I want to put it in the right place in the list of phrases. Do you
Put
understand?
it in. No, I didn't get this last part.
Yeah. The basic problem is I want to generate things. I want to, like, my grammar generates some stuff, and then I get all that rated. All the stuff that's generated gets rated. And then my grammar, and it has a particular order that it puts the things
Yeah.
in a spreadsheet. So we have all this things generated in a deterministic sequence, and then we have as columns what each rater gave for that. And now my grammar expands and I add more rules. And when it generates it out, it generates some new things. Um, so here it had this and this, and now it's generating 5 things in here. And so, how do I quickly tell that I'm generating new things? Um, I generated this. Oh, it's generating, right? So it generates this. Oh, I already have this. Oh, now I'm generating this. Oh, I don't have this. And then it generate. Oh, I already have this. So I'll pull in the data of what I have. Is it
Hmm.
clear?
Wouldn't it be like, I guess, a hash? I mean, just a dictionary of that, just the ones that you already have, and searching there, or
Right, but the dictionary isn't ordered. Um, right?
you want order? Mm.
Yeah. Um,
There is a version of it which is ordered, and in Python, I don't know like which language you use, but in Python there is ordered. I think ordered dict, and then that's it. Also similar to, it's similar what people do in, building, what do you say, cache data structures, like uh what's it, LSH caching, at least, sorry, LRU caching. When you have, basically, you tie dictionary or hash table with some order, like some another data structure, tie these two together. So that's something in interviews they ask you to implement. But I think there's this order dict, I think, or something like that in the Python, which is kind of similar. Yeah, it's the, I guess what you're asking is to be able to search efficiently, and at the same time being able to index it uh, with an order, right?
I think so. Yeah.
Okay.
What did you say? You said in interviews something. What did you say? In interviews, what this comes up?
Yeah, there is this design of LRU cache uh, and it's LFU cache, the coding problems. So these are kind of um, similar ideas that you want to be able to, access something in constant time and also have an order of them in some order that this should go first, this should go second. And then it's, I guess, a combination of like a linked list and hash tables, something like that. But you don't have to implement that. I guess there's this, I guess, order dict in Python should just work, or something similar.
So what does LRU and LFU stand for? Do you know?
Yeah, the LRU is a list recently used. Basically, the idea is that you want to have a cache of things, and then put the ones that are least recently used on one side of the priority, and then the ones that are like most recently used on one side. And then it's kind of a dynamic data structure. Like if you use one, you put it on top. And if you don't use something, it just goes gradually towards the end of the list. But you want to also be able to access any of them in, I think it's constant time or something like that. So that is, and I think ordered dict should be doing previous. Yeah, the order dict preserves the order. Well, it's, this is something like that, or like along the line of that should be something helpful.
Yeah, this is great. I would have never thought of this.
Okay.
Yeah, Python is amazing. They just
Yeah.
So, but the sort of concept of the algorithm behind the ordered dict is probably an LFU or an LRU cache. Is that right?
It is. It's not like the algorithm behind that, but it's. I would say like these are like similar concepts in the sense that you want to have quick access or constant time access,
Right.
and at the same time have an index or order on, I guess, a set or a collection. So that's where it comes.
And then LFU, do you know what that stands for?
That is least frequently used. So it's like one of them is in terms of like frequency of usage, the other on the recency.
I see, right. Frequency versus recency. Got it. Okay, great. So this solves the, these are great pointers for the, doing the quick, Francie, come on. Stop. Okay, so then very quickly, the last thing I wanted to ask is so the whole purpose of a language model is you put in a phrase and you get a probability out of it.
Okay.
Right?
Yep.
So and they build these things on huge corpora, and the BERT is the sort of one of these super fancy one that involves transformers. But a lot of people talk about taking BERT and then so it should be really easy to use BERT to help me solve this problem, right? So I could generate a ton of things, and then BERT can tell me if it's high probability. Then skin hurts is high probability, but heart is sweaty is low probability, and this should be very accurate. And I can probably even tell it, right? I could take BERT, and then there might be a rock band called Sweaty Heart. Probably is a rock band called Sweaty Heart. So that would have a reasonably high probability. But I think, I don't know much about BERT, but my thinking is that you bolt a layer on after it, and that's the layer that learns context. So, yeah, sure, sweaty heart is basically reasonably probable, but in a medical context, it's not probability, right? And so you adapt.
Yeah.
So, right, is that an approach that's likely to work, or it might work, or well, it probably won't work?
Yeah. So I guess if you want to use that, you can fine tune BERT on the data that you're generating from this grammar, which is because that is trained on like a huge data set and it's pretty generic language model. And then you can fine tune it on a specific, focus domain. And then that should be giving much precise results in terms of this particular domain.
Right. And this must be like something that there's tons of stuff on the internet on how to do this.
Sorry?
There
Yeah,
must,
yeah. There's tons.
and so and and I can use TensorFlow or Keras.
Yeah. TensorFlow, Keras, PyTorch. You can check in. There was this group called Hugging Face.
Yes.
They had a lot of different models and pipelines for using different language models, pre-training and fine-tuning. I don't know if they're still active, but at the time they were like one of the most active ones.
Yeah. I don't understand how they make money if they give all this stuff away.
Yeah.
Startup by some wunderkind, a German guy. I think I heard him speak once.
Yeah.
So
okay, great. So yes.
oh
I
yeah,
have to.
yeah. So that's great.
Awesome. Have to go, but it was great to talk to you again.
Yeah,
Hope,
and maybe we'll do
hope that
another one
helped.
on
Yeah.
ranking of news feeds.
Yeah, sure.
I'll think about it.
Okay.
Well, enjoy your virtual view.
Thank you. Have a great night.
Okay.
Talk to you.
Yep.
See you later.
Yeah.
Bye.